In 2000, the population of the world was 6.1 billion, and the relative rate of growth was 1.4%. Estimate the population of the world in 2050 using this rate, and estimate it using a relative growth rate of 1%. Compare your results. For exponential growth with populations, we have the formula n of t equals n naught times e to the rt, where n naught is the original population and r is the relative growth rate. In this situation, the initial population is 6.1 billion. Instead of actually writing out 6 billion, 100 million, I'm going to measure everything in billions. So I'm just going to write 6.1 times e to the rt, and we know that the relative growth rate was 1.4%, which is 0.014. So then our function becomes 6.1 times e to the 0.014t, where t is measured in years since 2000, and the population is measured in billions. Now first, we're asked to estimate the population of the world in 2050 using this rate. Well, in 2050 will be 50 years past 2000. So here we need to evaluate this function at 50. So we've got 6.1 times e to the 0.014 times 50. And when we approximate this, we get approximately 12.3 billion people. So if this rate were to keep up in 2050, we would have approximately 12.3 billion people. We're also asked to estimate this using a relative growth rate of 1%. So in that case, everything would stay the same except the relative growth rate would become 0.01. And when we approximate this, we end up with approximately 10.1 billion people. So if the relative growth rate changed from 1.4% to 1.0%, that would end up giving us a difference in global population of over 2 billion people. And the takeaway here is that a relatively small difference in relative growth rate, we're only looking at 0.4% here, but a relatively small difference can end up with a huge difference in the total population given a decent amount of time.